Welcome to Drop Table channel. New day, new video, new topic about very complicated piece of technology in modern browsers. This is the first video in video series about browser security policies regarding server requests. In this video series, I'm going to talk about different abbreviations that you may heard of or may not because they're quite new, like CORS, COEP, CORP, and all of this. All headers connected with them, and I'll show a lot of examples, how they work, how they shouldn't work, and how you should use them. And of course, we will sneak peek at the very secret JavaScript API that forbidden if you don't specify those headers and those policies, and we will try to use it. In this particular video, we are going to talk about how browsers protect our bank information, credit cards, accounts, and so on, and other private information from private websites. Also, we are going to talk about the difference between simple requests and why browsers make sometimes 2 requests instead of 1. And of course, we are going to talk about CORS. All these abbreviations with examples, of course, and with headers that connected with this. But first of all, please subscribe. I do understand that begging for subscription doesn't work. That showed my previous video. But this video is the first video. That's why to understand the full topic about those security policies, you need to know about every security policy. Please subscribe to not miss the next video about even cooler stuff. Okay, let's start. Hi. Okay, let's start deep dive into this course and all browser security policies regarding the server requests. First type of server request is the request of your own server, the same domain. Like you have domain, for example, mywebsite.com, and you request something from mywebsite.com. In this case, browser will use method named shilabuf method.
Just do it!
Yeah, it will just make this request without any checks, no problem. Just make any post, put, get, whatever request you have. It will be sent to your server. The response will return to your browser, and browser will just parse it and do whatever you say to do with this request. And this is the first part. The most interesting part is when you try to make requests to third-party servers to request, for example, scripts, images, data. Let's see what is going on in this case. I have 2 examples, and this one is the first example without any CORS. I'll show you. This is, as you can see, the folder called first. If you're not familiar with this syntax, this is Nginx syntax. Don't worry, everything is simple. The only thing you should understand that in this case, I don't add any headers. It just take the file that stored in my file system and ship it to, or take it from cache, and send it to the client if you request it. And let's see our HTML page that will request this file. As you can see, here I make 2 cross-origin. It means I send this request to another domain, 2 requests. In first request is the image. Yeah, as you can see, I requested crossorigin.com first. First it means without any headers, image. And the second one is the script. And also I want to check any errors that happens during this loading time on during script execution. It will help me to explain certain things a bit later. Okay, let's have a look at the script itself. Let's have a look at the script. Script itself, it's quite simple. As you can see, it shows you console log. All other things are commented. We'll talk a bit later about that. But let's see what happens. Yeah, let's load this first page. As you can see, the image is loaded. Let's see whether the script is loaded. Okay, let's filter all the requests by third-party requests because only we're interested only in those requests. Okay, and image, as you can see, no problems. Image, get request, script, everything, console, main script, everything works. Let's try to request some data and see how the browser behaves. Let's make a simple request. It simple get request, as you can see, it also cross-origin request. Yeah, but we will request some data. If you're not familiar with the fetch, no worry, we just send the get request to get this JSON data. If the request is succeed, we will print something and parse the JSON and print it in console. If something happens, we will catch this with the error. Great. Let's see what happens. Let's refresh our page. Open. Oh my god, something went wrong. As you can see, there is a lot of warnings or issues. Let's see. The browser tells us that there is a CORS error. What does it mean, the CORS? This C-O-R-S. It's cross-origin. It means like the request to third-party domain name, because as you can see, I on my local host, yeah, but all requests, as you can see, sent to crossorigin.com. Cool. That's cross-origin resource share. It means like how you can share resources. You can share resources with different domains. Cross-origin resource share. Sharing. As you can see, I don't have any headers, and this is the main point. Why it's done by browser? Browser try to protect you and all your private information. Let's imagine you are logged into your banking account, and there you have a cookie inside your in browser, yeah, and you just click on the link. I want my new iPhone, for example, somewhere in email, in junk, yeah, accidentally, or I don't know, and you click, and the browser opens the website I just want iPhone.com, yeah, and this website want to steal some information. This is phishing site that try to steal something, and if the browser will send a request to your banking, a browser will attach, if for example the banking website not that secure, browser will attach the cookie to your request, because it's done like that, because it's done with the domain of the banking, of your banking account or banking website. Yeah, and the banking server will respond you with some data. Yeah, and browser should protect you from this data, the private data from different domain, be parsed and read by this phishing domain like I just want iPhone.com. And browser will check the headers, whether the banking server allows to read this data on this website. In this case, as you can see, there is no headers at all. By default, browsers say, no, the information from third-party servers cannot be read on this website. You may ask, okay, if this data JSON that we requested, okay, that's clear our data, yeah, that can be stolen. For example, there is a credit card number or something that can be stolen. And okay, browser protect us and say, no, I'm not going to even parse this data because there is no header that allows me to parse it on this website. The banking server not allows me to do so. Okay, that's totally fine, but why browser allows to load images and scripts? Because they also may have some data, like for example, let's imagine your banking website not that modern and everything is displayed with the images. Yeah, and inside this image, that might be like your, for example, bank account or like credit card. It may happen. And browser allows to show this image. And this is the main point. Browser allows you to show it, not to get information from it. If you try to get this image and put it in the canvas, for example, to get the bytes, browser not allows you to do so. Browser tell like, no, there is no headers that allows you to read information from it. The same with the script. Technically, the script will be loaded, parsed, and if the script itself not send any data or save in the global, for example, variables, any data, you cannot reach the content of the script. It just loaded and does something. Yeah, the web JSON-P technique allows you to somehow provide the data, but JSON-P technique tells that you tell the server, okay, you should call this global function, and the script itself from the third-party server will call your global function and pass the data there. But this is the initiative from the third-party script, but not from you. You cannot get the content of it unless the script allows you to do so. Okay, in this case, you may say, okay, Vlad, I do understand that if there is no special headers, then the browser by default not allow us to get the data from this source, from this resources that was loaded from third-party servers. Cool. But what if this script, and I just remember that this is the third-party script. Yeah, that was, for example, I tried I just want iPhone.com, load the script from the website, like your banking website. Yeah, and what if there is an error, and I can create on my I just want iPhone.com some situation that this script failed. For example, I remove some public APIs, try to like proxy them and do something like to make this script to fail and reveal some information. For example, as you can see, let's imagine in this third-party script there is this error message like couldn't parse such a big sum of money on credit card, blah blah blah. And then, as I showed you, we can attach a global error handler that will catch all the errors from this window and take this message and try to parse it, probably get some information from there. And this is the valid technique, but let's see what browser by default, without any headers, will do in this situation. Let's refresh, open, see, console. Okay, we handled this error. Don't see, this is the browser error. We handled this, and let's see the object, this error object. Okay, it has generic message, script error, because again, browser take care about your all this privacy, take this very serious, and not allow you to access this content anyway. You cannot do so unless banking server, allows you to get access to them. Let's see this request. I'll explain a bit what is simple request and what is not a bit later. And of course, all the links, if you interested and want to read about them, all the links in the description. Okay, but right now, let's see. You see that here I added one thing. If we compare with the previous request that we have, like there were just a get request, here I just add small detail. I tell that the content type of this, of the response, should be JSON. Yeah? It means like the browser, when it gets this request, try to parse it as a JSON. It means like the browser itself should get the content from the server, yeah, and try to get the access to this content. Yeah. Let's see how browser will behave in this situation. F12. Okay, we have the same, almost the same problem, but we have 2 requests instead of 1. Why? I can explain it. Okay, this request is not that simple. As I said, because I said that the content type tells that it should be JSON, it means like the browser should have an access to the content and start parsing it. It means it at some point gives you ability to get the content from this response, which is not allowed, shouldn't be allowed, because there might be, because of some mistakes on the banking side server, there might be some very private information that cannot be revealed, but browser try to parse it. And or another example, let's say you send some put request that is can add more data to your bank. For example, add one more transaction to transfer money from one account to another. It also, like, if the browser will send this request and get the response back, yeah, and check these headers, it's too late, because the browser already sent this request, and the server will understand, okay, that's a valid request because you have cookies, everything is there, and it's a valid request, and create this new transaction. But the browser, when the response will be returned to the browser will understand, okay, there is no headers that allows it, okay, but it's too late to fail. And in this case, when the request is isn't simple by the browser definition, it sends options request. Options request does not allow any content. It's not a put, nothing. It's a separate verb, HTTP verb, a method, sorry, that tells, like, give me just headers. And let's see. In this case, I sent a request, and the browser sent a request, options request. That is not a get, nothing. We don't request any data. We just send, give me the headers. And we check, it's not allowed, because the headers does not contain this special header that tells, like, okay, I trust this domain and this domain can do this request. And the browser tells, no, I'm not going to do an actual request, this GET request that we have. I just fail before this request may cause any damage to your data. And right now you may ask, okay, what does means like simple? How browser differentiate simple request and not simple? Yeah. There is like quite a lot of rules connected with that. First of all, it should be like only get or post request. You may allow to specify only certain headers. For example, this header, content type, you may specify, but it can have only like plain text, multi-form data, and like, please see in the description. I list here, somewhere here. Like, I listed here. Yeah, you may see. Also, certain like there is very big amount of restrictions, and like only simple get or get or post requests with only like accept headers and like these headers can be sent without this options request first, because they treat it as a simple request and may not don't cause any damage on the web or on the server, and the server may send a response back, and the browser may check those headers in the response with the actual content. But all requests like put, patch, all these content types, all this stuff, a browser will send the first options request, get the headers, only headers, check the headers, whether this request is allowed or not. If it's allowed, it will send this request. If it's not allowed, it will fail. Cool. Next example will be with CORS header, and we'll see how this example, exactly the same example, will change. See you in a second. Right now we're going to look at the same example, but with CORS headers. First of all, we will take a look at our Nginx configuration. As you can see, again, if you don't understand, that's okay. But the only one thing you should understand that this add header, this is instruction for Nginx to add to all responses from this folder, yeah, from this path, this header, access, control, allow, origin. This is the main header, where you specify what domains can get access to the data that came from your website, from your server. For example, if I on my iJustOneIPhone.com send a request to bank.com, if bank.com will include my domain iJustOneIPhone.com into here, like just here, list here, then the browser will check my domain, the domain that the origin of this request and the domain in the headers, okay, they match. I will allow to have for you to access the data from this request. In this case, I put a star. It means like any domain, whether it's evil.com, google.com, something.ca, whatever. All domains have access to the content of this response. Great. Before we talk about this special options header, as you can see, I said if the request is options, yeah, and the method is options, I specify a bit more headers just to show you those methods not necessary. Sorry, those headers aren't necessary, but I want to show you. You may also, as you can see, together with the origin, that you may allow different methods. For example, here I allow options. As you remember, I said that the only get and put are simple requests, but here, for example, I allow get and options. I can include here post, everything. Yeah. And you may here list all the methods that you allow from that domain, that particular domain, to use. And the browser will check, okay, you allow get an option, but this request, for example, post, and the browser will not send the request. As well, you may allow set some headers. For example, here you may list content type headers or other headers, yeah, that you want to send to a server. And here you may specify, okay, for example, cookie or other headers. You allow browser to, like this domain particular, include those headers, and the browser will check, okay, if there are like other headers you set, okay, he will or it will decline, fail. But if you allow like all headers or like specific headers and only those headers exist in this request that was done, that is sent from the I just want an iPhone, then everything is fine and the request will be sent. Great. And all other is the same. Cool. Let's see. Example, as I said, the same. Image to the cross-origin. Let's talk about it a bit later. Script, also cross-origin. Event listener, script, the same. With aim to request, only the small difference is the URL, because right now we are trying to request the CORS, like the same script, but from different origin, different path where the Nginx will add those headers. Okay, let's see what will change. Okay, we refreshed, everything is loaded, third-party request, everything is the same. Okay, let's right now try to fail here. As you remember, the browser don't send an actual error message to you in this global error handler. It will replace it with generic script error dot, like full stop. Let's see, refresh. Nothing is changed. Script error. Why? If we take a look at the headers, there is a header that says my cross-origin server or banking server allows you to access the data inside the script. But the browser by default sends this script request in different mode. There are two modes how this request can be done: in cross-origin mode and usual mode. Usual mode will tell, like, the browser will send the request, get the request, parse the script, but won't check any headers. It means like it will behave the same as there is no headers. Because browser won't check it, it means like everything will work the same as there is no headers, like about like allowing something. But you may ask, okay, how we can make the browser, okay, please check the headers for this script and allow us to use the content of this script. It's easy, can be done with this attribute. This attribute can have two options, like anonymous and use credentials. Use credentials will add cookies and like allow authentication headers to the request, but anonymous will make the just request without any cookies, without anything. And with this attribute, you tell the browser, okay, I know that this is cross-origin request, and I want you to check the headers. If the headers does not allow to have access to this content, please fail. If they allow, I want to have access to this content. And let's see what will change in this case. Okay, we refreshed the page. See, everything is loaded. See, we have a header. Awesome. But let's see our error object. As you can see, right now it has the original message, because you tell the browser with this attribute that this is cross-origin request. Please check headers, and if the headers are okay, give me access to the content. And browser checked it. Okay, this script have access to this to the content of this script, and I can reveal the actual error message that may contain some private data, but the server that I request, for example, banking server, allowed it. And as you can see, we have this original message. Great. Let's see how exactly the same example will work in our first case. Let's open. Yeah, that's the interesting, the part that I forgot to show. Okay, let's open our first example. That's first, but as you remember, right now to the first example, yeah, we added this attribute. Yeah, it means like we tell the browser, please check the headers. And as you remember, we don't have headers in this particular example. Let's see what happened. As you can see, script isn't loaded and isn't parsed even. The browser get the headers, read them, like saw that you ask him to check the headers, check the headers. It's not allowed. I'm not going to parse JavaScript, and decline this request. Awesome. In this case, great. And probably you are familiar with one more attribute, integrity. The integrity attribute allows you to specify some hash that you calculated with some algorithm of that hash is calculated from the script itself, the text of the script, and it's used by the developers to make sure that the content of the script isn't changed. For example, you get your data from some SDN server, and you get, for example, React library or some other library, and you want to make sure that no one on this third-party server changed the content of the script. And you calculate the hash, yeah, put here hash, and what browser will do is, if the browser sees this integrity attribute, it calculates, load the script, calculates the hash from the content of the script, and compares the hash. If the hash matches, everything is okay. If not, browser throws an error and this script will be ignored. But this integrity attribute you cannot use without this cross-origin, because you need to specify, because the browser, before reading the entire content that may contain some private data, and yes, technically you don't have access to this browser parsing and all this inner code that browser does, but because of this spectra and other security vulnerabilities, you may probably have it. Potentially you can do so, because it's like parallel, it will be probably run in parallel processes, but still you know that the spectra and all this connected security vulnerabilities connected with that may allow, like, you may have access to this even if they are in the parallel parallel processes. Okay, and that's why the browser requires you, before reading the content and calculating the hash, requires you must set this cross-origin header for me to check headers first. If headers allows me to read this script, it will take the script text, calculate hash, compare. If you don't have this cross-origin, browser technically not allowed to do so. Cool. Great. Exactly the same thing can be done with the image. Right now, even with the headers, you can take this image bytes, put them into canvas and try to read the bytes itself. You will not allow it, because it's third-party request and the browser won't check any headers. But if you want to do so, easy. You can add the same cross-origin attribute, and then browser will check this image headers, mark them, okay, we're safe to parse it, or to we're safe, like the server allows this particular domain to have access to the bytes of this image, and you can get it from the canvas or whatever. Great. Cool. This is about our static request. Let's see what happens with our request for data. Yeah, first of all, let's make a simple request. This simple request, we get data. Cool. Let's refresh the page. Oh, sorry, that's the first one. This one. Let's see. Everything is parsed. As you can see, response is okay. And here's our JSON data. Awesome. Let's see the request. There are only one request for data. The browser, as far as it's a simple request, the browser sends the request, get the response. Before parsing and anything, it read headers, check, okay, headers allow everything. This domain is included in this list. Awesome. I will allow you to have access to the content. Okay, let's see what happens with the not that simple request. The same request, yeah. Let's refresh it. F12. And in this case, everything passed. Yeah, you see that we have the same data, but we have two requests and two succeeded. First, as you can see, options request. The browser sent an options request. The Nginx returned our headers that I showed you a few minutes before. As you can see, and browser check. Okay, this is GET request. Yes. GET method is allowed. Yes, allowed. Cool. This request has this content type header. Whether it's allowed? Yes, all headers allowed. Cool. The origin of this is localhost, but you're requesting from crossorigin.com. Is this localhost like allowed? Yes, all origins allowed. Cool. It's safe to send this request. The request is sent. And after browser won't check this headers, it just like get the content and allow you to use it. Great, and that's it about CORS. This is all about cross-origin request. As you can see, it's not that hard. You just need to understand like what is it you have a simple request or not simple, whether you need cross-origin request or not cross-origin request, and whether you need to have access to the content or you want, like, for example, actual error message or not, and you want, like, for example, have access to image and so on. Cool. In next videos, we will going to talk a bit more deeply in those headers, and we'll understand like how you can specify, for example, force the entire web page to follow only strict rules in CORS or other headers, how you can specify whether this web page is allowed to send the cross-origin request or not, and how those headers can open an access to some hidden, very secret and very, very useful, very cool features from JavaScript that I really keen on to see. Cool. Thank you for watching. See you in a few days. I hope you enjoyed this video. If you want to like it. Just click this like button. If you want to leave a comment that you don't understand something or just want to cheer me up, motivate me, that probably I'll take a few courses about how to make a cool transition, then just leave a comment. If you want to share this video about how awesome it or how much information you get from it, please share this video. And see you on GitHub and in next videos that will be in a week or so. Thank you for watching.